There's a lot of mis and disinformation out there, and everyone seems to know the truth about everything. And you've no doubt either been told to do your own research or heard from people who claim that their opinion is correct because they've done the research. But what does that even mean? The quality of the data that we use to make decisions radically impacts our beliefs, behaviours and results in life. So it's important that you do indeed do your own research, or at least understand what research is. So in this video we explore some of the different types of research to see if we can't clarify the definition, and I'll finish with the neuroscience of how bias plays into our interpretation and approach to research, just to help you take a step back and be a bit more deliberate in your decision making. At the end of the video, we'll look at why presenting data alone rarely changes people's minds, so stick around. Ahoy, Peter here from Bryter Training, and today we're taking a super quick look into research, what it is and what you should look out for when someone says that they've done it and that they know the truth. As always, if you find this video useful or thought-provoking, we're grateful for any interactions via comments, likes, subscribes or shares. So let's jump in. Pick a subject, any subject. COVID, quantum physics, the environment, even the shape of the planet, and I'll show you someone who's done their research and knows the truth. Spend 5 minutes on any social media platform and you'll be forgiven for thinking that everyone is an accomplished researcher. Not only do they know the process, but they've apparently discovered the holy grail whereby their research has resulted in absolute fact. And it's literally at the point where the most uneducated or inexperienced people can argue with scientists, doctors, professors, and epidemiologists. Unfortunately, there's a lot of cognitive dissonance out there, and people mistake opinion with fact, not realizing that just because there's a reference somewhere that supports their point of view doesn't make it true. Now, I know nothing about geology, but I can create opinions on how the Earth formed and the forces acting on it. I could probably even find a website somewhere that will support my opinion. That doesn't make me right. I mean, come on, some people think the Earth formed 2,000 years ago, and others say 4.5 billion years ago. Someone's wrong, and in my opinion, it's less likely to be the scientists who have spent a lifetime studying the topic. Now, does this mean that nobody is allowed to have an opinion unless they're a doctor or a specialist in a particular topic? Of course not. However, when an opinion is stated as fact and has negative effects on people, business or society, then it's worth calling a timeout. So in our videos to date, we've been looking at educational neuroscience and specifically the physiology of learning. We've looked at the brain as a social organ, the importance of overcoming stress and threat, neuromyths, hardwired functions of the brain, and neuroplasticity relating to learning. Learning, education and training are essential across all aspects of life, and when you consider that the brain keeps on changing throughout our lives, it becomes even more important. And it's expensive. Personal education or professional development is a multi-billion-dollar industry. Yet most of the content will be forgotten, and a whole lot of the programs out there are pretty average to begin with. So it seems reasonable that if you're looking at a course, hiring a trainer, or relying on data from someone, then that they can give you some convincing evidence-based explanations as to why they and their programs are likely to meet your learning needs. Nowadays, everyone has a platform to share their opinions, and there's a huge amount of information available at our fingertips, so it can be really hard to know what's right. And the brain, of course, is trying to sift through it all to give you what it thinks you need. However, it doesn't know if something is quality data, or just from someone who wants to make $1, or raise their profile, or is an idiot, or just wants to watch the world burn. A lot of information out there is either misinformation, aka misconception, myths and mistakes, or disinformation, so inaccurate information that's intentionally spread, or marketing, because why let the facts get in the way of a potential paycheck? So how do you sift through and find the good stuff? How do you validate the claims made to make informed decisions? So let's get the definitions out of the way. Everyone does their research. So what does that mean, or what should that mean? Firstly, I want to clarify that research isn't always about laboratory work. In everyday use, research is about informally gathering information to answer a question or find a solution. So that can be as simple as checking with the council what day the bins are collected, or using paint samples to decide what colour works best in your home. Now, scientific research, however, is the systematic application of specific and replicable methods to explore, understand, test, or change subjective or objective reality. Hence, whereas informal research gathers information, scientific research converts that information into data. So data is information that's been collected, then organised, verified, manipulated, and analysed through replicable methods to explain or discover new knowledge. And there are different types of research. Now, many people have heard of the scientific method or the hypothetico-deductive approach. So this is where one makes an observation, hypothesizes an explanation, creates an experiment to test that hypothesis, and then draws a conclusion based on the result. Now, if the hypothesis is valid, they then present that finding for scrutiny and testing, which is really important. Or if the hypothesis is false, they then go back to the start. Now, other common terms that you'll hear include quantitative research, so think quantity, which looks at numbers and measures. Or qualitative, so think quality of experience, which looks at subjective descriptions and experiences, so the type of data you'll see from interviews, surveys, or focus groups. There are literature searches and literature reviews, which involve gathering and analysing existing information on a topic, but formally defining inclusion and exclusion criteria, allowing insight into your approach, the repeatability, and bias. And then there are desktop studies. These are sometimes called meta-analyses, and they take the results from existing studies and they apply that data to a new question. And these have pros and cons. They're good because sometimes people just don't have the time, funding, or opportunity to conduct entirely new experiments, trials, or studies, so using existing data means that new ideas are always explored. But they can also be bad because that data used was originally obtained based on a very specific approach and a set of criteria. Hence, the end result may have already been skewed by previous bias or design factors. Still, my point is that when you hear people say they did their research, you can see why it's important to clarify whether they informally read a website or conducted a scientific study. We really should be replacing informal research with I briefly looked something up and got a simple answer that suited my model of the world, since most informal research is simply supported opinion. And finding data doesn't mean finding facts, since there are few topics or points of view out there that I couldn't find reputable data for if I was so inclined. But just because I can find references doesn't mean my point is true. The take-home message is that informal research and scientific research are different. Informal research is potentially a blend of quality data, uninformed opinion, marketing, and pure rubbish, whereas scientific research is a process. My unresearched hypothesis is that most people who discount the scientific and structured approach to research do so because their views wouldn't stand up to the scrutiny. And you can identify it by listening out for things like deflection, where they'll say things like scientists are just owned by industry, or generalizations, where they'll say things like our own research shows that people like our programs, but then they won't offer you access to the references to prove those claims. Whether it's finding a good training partner, the vaccination debate, global warming, choosing between paper or plastic straws, you'll face a lot of conflicting opinions and options. So why, if everyone deals with facts, and especially when everyone's done their own research, then shouldn't we know what is correct? Well, no. Firstly, because of the reasons I mentioned earlier around misinformation, disinformation and marketing, and idiots, but also I introduce you to bias. Epidemiologist 𝐥𝐢𝐤𝐞 has famously argued that many of the published research findings are false, holding that those research findings are simply accurate measures of prevailing bias for many scientific fields. Now, this kind of science finds its way into the popular media or is used to support management decisions, teaching approaches, and even political ideologies. And it's not science, it's referenced opinion. In essence, bias is an inclination or a prejudice toward a particular point of view. There are many different biases, so the topic would require its own video. Suffice to say, the brain looks for trends and patterns to predict the future, keep us safe, and to automate our behaviours. Now remember, upward of 90% of what you do is unconscious, and your biases alter your behaviours. And yes, you have biases. Even the act of thinking you don't is biased. Now, bias isn't always bad. It gives us a framework to help us look for evidence of an insight that may be derived maybe from inspiration or personal experience. This bias then provides the impetus to find evidence and help others or contribute to global knowledge and an understanding of a topic. And ideally, if that research disproves the initial hypothesis, then it should also be respected. I remember listening to a video by Dr. Brené Brown, who often mentions that her own research into social work results in her needing to change her opinions or her understanding of the world. And ideally, this is what research should do. Change our perspectives based on the result and not change the result based on one's perspective.
And I'm going to talk to you today. We're talking about expanding perception. And so I want to talk to you and tell some stories about a piece of my research that fundamentally expanded my perception and really actually changed the way that I live and love and work and parent.
Also remember that facts are only true based on the available data or understanding at a point in time. Hence, it's important that research doesn't lead to a rigid dogma, but encourages people to consider growth. So neuroeducation shows us that people will always have a degree of bias, since most of their behaviours are automated, requiring many facts to be held onto. But their neuroplasticity shows that we can change those facts, and thus our beliefs and our experience in life. However, it's not as simple as just asking a question or reading new data. Now, my own cynical opinion is that people are only open to learning if there's a vacuum in their worldview that desires clarity, and once people have an opinion, they're less likely to welcome change. Why is research important, and why do people resist quality evidence and processes? So let's go all the way back to the basics of the brain. The brain seeks patterns, and we automate much of our behaviour, and we crave stability and predictability. So any disruption to that stability triggers threat, and threat reduces our cognitive function. Hence, you can rarely convince someone with data alone, and we see why someone who's watched a YouTube video claims that their research is as extensive or valid as that of an epidemiologist. So time flies when you're having fun. That's all I've got time for today. This is a fascinating topic and one that has implications on personal beliefs and behaviours, business and leadership, and how we make decisions. Now, the quality of the data that we base our decisions on is impacted by design, intention, and bias, so our own, but also those presenting the opinion or the offer. So when you hear opinions or need to sign on the dotted line in the future, just stop and ask yourself, what happens if the information is wrong and you act on it? And then what happens if the information is correct but you don't take action? And then consider a systematic, structured approach to doing your own research and scrutinize the data to make better decisions. All training and development should be evidence-based, measurable, and supported by actual research, not just effective marketing. So if you're interested in research-based training for your organization based on sound neuroscience principles to improve culture, productivity, and performance, then drop us a line to discuss options. Our contact details can be found in the description below. Thanks again for watching, and have a great day.